Okay, right. In last class, Pratik, we were discussing about how to find the integration by parts. We have to do a few more questions in that section. I'll be starting with question number one, part A, that is x sin x. So, how to do this integration? So, here, exercise, sorry, 60, question number one. Exercise 60, question number one, part A. We need to do the integration for x sin x. Right? Okay. The question is to work out for x sin x. Yeah. So in this case, you can see how to understand this question, because in this section itself, it mentioned that you have used the integration by parts, but if it is in a just general question, how to verify whether it's integration by parts? This is a way of doing it with it. Initially, you can understand that it's a product of two different functions. If you happen to see a integration between two different functions, see whether consider one as a power of another power function and see whether the differentiation of that is available over here. Just check whether the differentiation of this one is over here. Just like this is the way of thinking of this question. This is the way. So we will assign this is initially thinking this way, sin x to the power 1 x. Now see whether the differentiation of this is available here. For example, just like this. You get sin x to the power 1 and here it was cos x. Then here the differentiation is available in this point. So simply then you can say, without having an hesitation, you can say this is sin x squared over 2. So simply you can write it. But here the differentiation of this is not available here. Or you can check this way, x to the power 1 and sin x. Whether the differentiation of this is available here. No, it's not. Just for example, just like this, x to the power 8 and here it's 1. So simply you can say this is x to the power 9 over 9, like that. There is no need of working for this one, just integration by parts for this. But just to show some example, I'm going to explain in this matter. So in this case, now see whether it's the differentiation of this is not available here or differentiation of this is not available here. In this approach, what we need to do is now there are the other two approaches where we can go ahead with integration by parts or integration by substitution. As I mentioned you, the tip to understand whether it's integration by parts or substitution is see whether are these functions are related, similar functions, similar type of functions. What do you mean by similar type of functions? Similar type of function is just like this. X square root of 2x plus 1 is a similar type. Then integration by tan x, sin x. These are similar type of functions. For example, e to the power 3x, e to the power 4x. These are similar type of functions. So here they are not similar type. Therefore, you have to go ahead with the integration by parts. So I'm using a different color to explain this question today. Then the answer. Then we need to identify whether which one is u and which one is dv by dx. We need to define what is u and what is dv by dx. That's a fact where we have to work out. Right? Then, according to the relationship u, the first priority go to learn function. There is no learn function. Second priority to go if it is differentiated at the, if you simplify at the first, some kind of a differentiation, yes, u. This is differentiated. Third priority to go to convert in the next differentiation. So here it's not a problem. You can consider u as x. Therefore, du by dx become 1. Then dv by dx is sin x. Then v become integration of sin x is minus cos x. So according to the relationship, integration is equals to uv minus integration by v du by dx. That's fact. So u is x, v is minus cos x minus integration by minus cos x into 1. So this is turned up to minus x cos x minus minus turn out to plus integration of cos x is sin x plus is the final answer for this. That's a way of doing this kind of a question. Right? Okay. Let's move up to another question and let's try to understand the situation, right? Okay. Yeah. Right. Then Pate, let's go to another, the second question. We did the second question, question part C, sorry, part C. I'm referring to question number 1, part C. The part C is the integration of x sec squared x into sec squared x dx. Here also the same condition. None of the differentiation facts are available as the other one, so you can use it. So here you can consider u. I can consider u is equals to x. Therefore, du by dx is equals to 1. dv by dx is equals to sec squared x. Therefore, v is equals to tan x. Right. Yeah. Then if you want to find out I is equals to uv, u is x, v is tan x minus integration by v du by dx, tan x into 1. So then we can say x tan x minus, what is the integration of tan x, Pute? Children, can you remember? Integration of tan x is ln sec x plus tan x. That's how we do to get this answer, right? Okay, that's a way of getting this fact of it, right? Okay. Then if you move up to question number here, these are two questions which I am discussing about. Then this part of it, x sec x tan x. Integration of x sec x tan x dx, right? Okay, over here again, we have to consider this x as u. U is x, therefore du by dx equals to 1, dv by dx equals to sec x tan x. Then we become integration of sec x tan x is sec x, right? Okay. Then yes, then what we can do with this is this part of it. Then you can say I is equals to integration of v. V is sec x, uv is x.
Excuse me, sir.
Yes. Yes.
So
Yeah.
in the previous question, now v is tan x, no? Because when you integrate dv by dx,
Oh, okay. One second. Just
it is
pause.
tan x.
Pause for a minute. Oh, क्या मुकद्दर?
Hari sir, man dakka dank. Hari. It's okay. Adakka x nena sir, like tan. Okay.
Oh, that's x, yeah. Right. Okay, here. Then integration of sec x then method into 1. The integration of sec x, how do you get it? Yeah, the method into here, it's turned up to x sec x minus, what is this one? This is ln sec x. plus c, because if you differentiate sec x, what do you get, Pute? Like how do you verify it, Pute? Ln sec x. If you differentiate ln sec x is 1 over sec x, differentiation of sec x is sec x tan x. Sec x cancels and turn up to just only tan x. That's how it comes back. Okay. Then that is a way of doing that kind of questions, Pute. Right. Then if you move to question number 2. So Priyambana make just like a question similar to this. 3 ln x, x ln x make questions 5 we already did, and we because we did these questions in last section, Pute. So similar questions to this. Ln x over x cube, Pute. Ln x over x cube. Question number 3, part C. Ln x over x cube dx. So if you do this, see what you call that? It's when you select it, you have to consider u as ln x. Therefore, du by dx. You have to consider u as ln x. Then du by dx become 1 over x. Then we can get dv by dx is 1 over x cube. That means x to the power minus 3. Then v become integration of that x to the power minus 2 over minus 2. Then we can say I integration is equals to uv. U is ln x, v is you can brought this to they can, if you simplify this is turn up to minus 1 over 2x squared. Minus 1 over 2x squared minus integration by v du by dx. Du by dx is 1 over x. Then this turns into minus ln x over 2x squared minus turn up to plus. Here this is the integration of 1 over 2. This is x to the power 3, that is x to the power minus 2, minus 3. Right. Then this is turn up into minus ln x over 2x squared plus 1 over 2 into x to the power minus 2 divided by minus 2 plus c. Then this is turn up to minus ln x over 2x squared minus 1 over 4x squared plus c is the final answer. I think you can understand how we did this question. Just a little bit of minimize for you all. Okay, Pratik. Right. Then let's move to another question. Ln x squared we did. This question also you can manage. And if you come up to a question like this, Pratik, question number 3, x squared e to the power minus x. This is not question number 3, but this is question number 2. I just made a mistake. This is question number 2, part C. Then, if you move up to question number 3. Question number 3. Question number 3, if you turn up to x squared e to the power minus x. Then put the initially we will consider this is the integration by parts for this question. Let's work out down here. Initially I'll consider u as x squared. Therefore, du by dx is equals to 2x. Then we can work out dv by dx is equals to e to the power minus x. Therefore, v is the integration is minus e to the power minus x. There with that, you can say I is equals to uv. U is x squared, v is minus e to the power minus x minus integration by v minus e to the power minus x du by dx. Du by dx become 2x dx. So with that, this is turned up to minus x squared e to the power minus x minus minus turn up to plus 2x e to the power minus x, right? Now what you need to do is here you need to make them to this one again, for this part again, you need to apply the integration by parts. Then we will consider here u as 2x, that is du by dx become 2, dv by dx is e to the power minus x. Therefore, we become minus e to the power minus x, right? With that, you can say I is equals to minus x squared e to the power minus x plus, if you do this, again for this part, again you can put uv formula. U is 2x, v is minus e to the power minus x minus integration by v du by dx. Du by dx is 2, right? Then let's go ahead a little bit of it. Then I is equals to minus x squared e to the power minus x plus, sorry, it's not plus, then minus this turn up to minus, minus 2x e to the power minus x. Here, minus minus turn out to plus, integration by 2 e to the power minus x. 2 e to the power minus x. Here, but these two minuses get turned up to plus 1 over here. Then we can do the last part of it, but then you can simplify as minus x squared e to the power minus x minus 2x e to the power minus x minus 2 e to the power minus x. This is the final answer for that. If you want, you can take e to the power minus e to the power minus x out, and you can write it as x squared plus 2x plus 2. That's the answer what you to obtain for this kind of a question. Right? Then yes, I just a little bit of minimize this question. You can see it much clearly. So this is the answer for that. Right, let's move to the next question. Then if you try to do the question number just like C, 12x squared, 3 plus 2x to the power 5. X squared 3x plus 3 plus 2x to the power 5. Three plus 2x to the power 5. This is a question. Right. Yes. Then initially, for this part, what you can do is, so if you go into the substitution, even here the order is kind of bigger than this. So you can use a substitution, but it's kind of more complex if you go into the substitution. So it's easily, we can go ahead with the integration by parts for this question today. So what you can get here is, you will consider u as 12x squared. Therefore, du by dx. Du by dx become 24x. Then we will consider dv by dx is equals to 3 plus 2x to the power 5. Therefore, we become integration of this 1 over 2, 3x plus 5 to the power 6 over 6. That is 1 over 12, 3x plus 5 to the power 6 is the answer for that, right? Then you can do this integration. Then you can say I is equals to uv. U is 12x squared v. 1 over 12, 3x plus 5 to the power 6 minus integration by v du by
Sir,
dx. Yes, Pradip, I can. Yes, what is it?
sir,
Can
what is now? How did the 3x plus 5 come?
where? What I'm doing.
Uh,
Sorry. Don't look at screen. It's not 3x plus 5. It should be 3 plus 2x. Wait, let's just add this question into it. Yeah, sorry, I just made a mistake, right? Okay. Then put here, initially we have to take u, 12x squared, therefore du by dx is equals to 24x. Then dv by dx is equals to just 2x plus 3 to the power 5. There with that you can say 1 over 2, 2x plus 3 to the power 6 over 6. That is turn up to 1 over 12, 2x plus 3 to the power 6. Then how can you go ahead with this? Then you can say I uv, u is 12x squared, v is 1 over 12, 2x plus 3 to the power 6. So that is turn up to x squared. Sorry, just we'll do the rest of it and then I can come up with that. This is uv part is this. Then uv minus integration by v. V is this bit. 1 over 12x, 2x plus 3 to the power 6 into du by dx. Du by dx become 24x. So this is turned up into this 12 and 12 get cancels. X squared, 2x plus 3 to the power 6. This 24 and 12 just turn up to 2. 2x, 2x plus 3 to the power 6. Right. Okay. Now what you can get here is that again you can substitute. You can put uv formula for this. I become uv equals to 2x. Therefore, du by dx is equals to 2. dv by dx is equals to 2x plus 3 to the power 6. Therefore, we become 1 over 2. 2x plus 3 to the power 6 plus 1 is 7 over 7. Right, this is turned up to 1 over 14. 2x plus 3 to the power 7. Right, okay. Then, if you go down a little bit of it, then you can say I is equals to from the first part of it, x squared, 2x plus 3 to the power 6 minus uv. U is 2x, v is 1 over 14, 2x plus 3 to the power 7 minus integration by v du by dx. Du by dx is 2. Right. Then, if you simplify this, what do you get? Let's turn up to this part of it. I x squared times of 2x plus 3 to the power 6 minus this is turned up to the x over 7. X over 7, 2x plus 3 to the power 7 minus 1 over 7. This is 1 over 7 2x plus t to the power 7. Now you can do this integration easily. So this is turn up to x squared 2x plus t to the power 6 minus x over 7 2x plus t to the power 7 minus 1 over 7 into 1 over 2 2x plus t to the power 7 plus 1 is 8 over 8 plus c. Minus 3 to the power 8 plus c is the answer for that. That's a way of doing this kind of a question. Is that clear? Yes. Then like that you can do these questions. Yes. But is there any other things where we have to concentrate rather than this? Yes. Then yes, if you come up with this kind of a finite integration with a x e to the power 2x, this question number 4 like that. So I think you can do the rest of the questions. It's not that hard for you to manage. Yeah, x e to the power 2x. The question is put a x e to the power 2x from 0 to ln 2. Yeah. Right. Initially, we can consider u. I'll consider u as x. Therefore, du by dx become 1. dv by dx is e to the power 2x. Therefore, we become integration of that. Integration is 1 over 2 e to the power 2x. Therefore, you can say I is equals to uv. u is x, v is 1 over 2 e to the power 2x minus integration by v du by dx. du by dx is 1 with it. So that is turned up to x over 2 e to the power 2x minus 1 over 2 into 1 over 2 e to the power 2x, right? Then if you do this, you will understand that this is x over 2 e to the power 2x minus 1 over 4 e to the power 2x. Now they have given the ranges 0 to ln 2, right? Okay. Now I just work out the rest of the part over here. So if you put ln 2, ln 2 over 2 e to the power 2 times of ln 2 minus 1 over 4 e to the power 2 times of ln 2 minus 0 substitution is first part is 0 minus 1 over 4 e to the power 2 times of 0, right? So this is turn up into ln 2 over 2. Just put in the calculator and you can understand that this turn up to 4. 4 minus 1 over 4 into 4. Minus this is turned up to plus 1 over 4 e to the power 0 is 1. So this is turned up to 2 ln 2 minus 1 plus 1 over 4. So the final answer is ln 2 ln 2 is ln 4 minus 3 over 4 is the final answer for that. That's a way of doing this question. Right. That's a way, yeah, you can do this kind of a question.